We would like to acknowledge the Whadjuk Noongar people, the traditional custodians of the land on which Curtin's University's Bentley campus sits, and pay our respects to the elders, both past and present.
The aim of the group was to implement effective environmental and technological strategies and systems in order to maximise the energy efficiency and performance of Tannock Hall, whilst maintaining its essence and functionality. Whilst the existing environmental and technological systems employed have been amicable, the group has identified a number of simple and effective solutions which dramatically improve the building's performance. What follows is a brief discussion of the investigation into the existing structure, the implementation of the proposed strategies and the performance, as well as the contradictions and compliances noted.
Tannock Hall is located in the West End Heritage Precinct of Fremantle, on the corner of Cliff and Croke Street. It is a temperate climate, Zone 5, that has hot dry summers and mild wet winters. The average annual temperature is around 18 degrees, with a 6-month average sitting in the comfort zone, according to Climate Consultant 6 analysis. The main morning wind comes from the east, and the afternoon, which is the strongest breeze, comes from the southwest. May through to September requires some level of heating.
The vertical elements of Tannock Hall are comprised of a double brick wall to the north facade and limestone block veneer to the remainder of the building. There is no wall insulation. The windows are all single glazed, which have a poor U value, and there is a glazed screen around the first and second floor lecture and computer room windows. Solar radiation plays a crucial role in the energy efficiency of a building. It directly impacts solar heat gains and provides natural lighting, thereby mitigating the need for electrical lighting systems. Apart from the north facade, Tannock Hall has good access to solar radiation and natural light, which enter through glazed elements on the west, east and south facades.
Tannock Hall utilises high thermal mass in limestone walls and the concrete floors. This is recommended by Reardon, McGee and Milne in 2019 in their article Thermal Mass. It helps to delay solar heat absorption in the hot periods of the day and re-release in the cooler times when needed. Reardon and McGee in 2013 recommend for passive heating and cooling that the glass to mash ratio for temperate climates should be between 12 to 15% of floor area, and in Tannock Hall it fits this recommendation perfectly. The total window surface area to floor is 11% for level 1 and 14.77% for levels 2 and 3, with a total window surface area of 13.5% per floor surface area for the entire building. The use of smaller windows behind the solar glazing screen enables for ventilation to be controlled in the spaces. Tannock Hall building does not have any integrated greenery on the skin facade, roof or internally. There are 2 trees located on site in the car park. We have studied various precedent buildings to gain environmentally sustainable ideas that are currently working. We have looked at Council House 2 by Mick Pearce, The Commons Nightingale 1 by Breathe Architecture, Pixel Building by Studio 505, the Docks Library by Hayball, the Bullet Centre by Robert Hull Miller Hull Firm, and Surrey Hills Library by Frances Joan Moorhan Thorpe, FJMT.
The Council House 2 building employs a number of key features which improve its energy efficiency. These include solar panels to the roof, wind turbines which remove excess heat and generate electricity, recycled timber louver screens to the west facade, balconies to the north which provide an external environment for occupants but which also act as light shelves blocking excess solar radiation, a perforated metal screen on the east facade which reduces solar glare, chilled beams and a phase change material which remove excess heat in the building, and an automated window system allowing cross ventilation in the evening.
The Pixel Building was Melbourne's first carbon-neutral building and utilises green techniques for heating, cooling and integrated greenery. It uses water pipes in the concrete flooring to cool the building radiantly and through convection. A heat exchanger preheats and pre-cools air coming into the building, and operable windows facilitate night purges. Extensive green roofs insulate the roof space whilst collecting water. Perimeter plantings also capture and filtrate water and aid with cooling the floors. The Commons by Breathe Architecture is an 8-star energy rating building. It utilises greenery on the front facade in a cable trellis system. It utilises wisteria, which is full leaf coverage in summer to help reduce unwanted solar gain, and then in winter it drops its leaves to allow wanted solar gain for passive heating. It uses a direct green wall of ivy on the west facade, which helps insulate against train noise and heat in summer. The south facade has planter boxes on each balcony that provides privacy and insulation. The roof also utilises an intensive garden planter box system that produces edible food. This is expected to reduce heat absorption by 10 to 22 degrees.
The following proposals are suggested for the vertical elements of Tannock Hall in order to improve its energy efficiency. Firstly, wall insulation will be added, particularly the Knauf Jetstream Max wall insulation, which has an R value of 8.8. Secondly, the single glazing will be replaced with double glazed low E glass from Viridian. The solar heat gain coefficient and U value of these windows are particularly good, being 0.22 and 1.39 respectively. Furthermore, as good construction practice, the builders will be required to construct the building as airtightly as possible, thereby reducing the infiltration rate and, in response to the Building Code of Australia requirements, the lighting systems of the building shall not be allowed to exceed 8 watts per metre squared. Lastly, louvers will be added to the windows on the east and west facades of the building, which will be responsive to the sun's position. The louvers will therefore always be in an optimal position to limit excess solar heat gains and reduce the cooling loads of the building.
Tannock Hall requires an unusual approach to its roof skin due to its planned future upwards expansion. To implement the lessons learned from the Surrey Hills Community Centre, the roof skin modifications had to be mounted onto an impregnated plywood on felt system that could facilitate the roof's fabric reuse after the building's extension. The improved system of underside insulation, felt, plywood, aerosol, bitumen and ballast provided a greater thermal mass and an increased R value of around 5.1 against the existing R value 0.53. This is a 960% improvement over the current system. After investigating the hydraulic solutions implemented by Seattle's Bullitt Centre, the retrofitting of a rain collection system to provide water to Tannock Hall was implemented. The chosen system, when combined with Wells 4-6 products, has the capacity to supply a significant portion of the building's needs for grey and potable water and also reduce the demand on main supply by upwards of 44%. Systems such as sewer mining, hydro harvesting and composting were also considered, yet due to the scale of Tannock Hall, they proved to be neither financially or functionally viable. The Library at the Docks is a floating building incorporating many acoustic systems to counteract the unusual site and material properties of the construction. Through the inclusion of some of the relevant acoustic treatments, Tannock Hall can become a more successful and enjoyable building to inhabit. The use of Knauf acoustic insulation in both the external and internal walls substantially reduces the sound transmission between spaces, whilst the internal recladding, utilising both acoustic gyprock and perforate acoustic plywood, improve the internal spaces to a reverberation time more conducive to their primary use.
To improve Tannock Hall's passive heating and cooling, it would be beneficial to utilise a green roof for insulation and water collection. This water could then be used to chill the concrete floors for radiant and convective cooling. A geothermal heat sink would be compliant with this idea. A chimney stack would also help to release extra solar heat gain and draw through fresh air into the building. Operable louvers would enable night purging. Taking ideas from both the Commons and the Pixel building, it is recommended to utilise a green roof for water collection, environmental ecosystem stimulus and thermal benefits. A green facade on both the southern and western wall would be beneficial for shading and insulation and aid in passive heating and cooling. An internal green wall would enable air filtration and mental health benefits.
Overall, the changes and propositions implemented at Tannock Hall have had a significantly positive impact on the building. The energy usage has been reduced from 87 to 24 kilowatts per hour per metre squared per year. This represents a 72.4% reduction in the energy consumption of the building. The solutions proposed are effective and simple to implement and do not change the essence or function of the building in any significantly detrimental way. It is therefore the opinion of this group that the overall goal we set out to achieve both individually and as a collective has been successful. Thank you.